Hello, this is Ali Kotami with SCS Engineers. I thank you for taking time out of your busy schedule and listening to this presentation. This is a short presentation and the subject of it is gas removal from leachate collection pipe systems. Gas pressure buildup is a well-documented phenomenon at the liner level and within the leachate collection pipe systems. Gas pressures, very high gas pressures, could potentially impact flow of leachate within geocomposite drainage layers and naturally impact the removal of leachate from disposal cells. Also, gas pressures could generate hazards during maintenance of the LCS pipe, which the maintenance could be removal of submersible pumps from the riser pipes for maintenance purposes, or performing pipe cleaning using high pressure nozzles. Removal of gas pressure from LCS pipe can be done in several different ways. One of them could be connecting the LCS pipe and possibly the riser system to a vacuum source around the sump area, or connecting the LCS pipe to vacuum source at the high end of the pipe where liquids are not at the high level, or you can bring vacuum to the gravel bedding around the LCS pipe, which is the subject of this presentation. At this point I'm going to show you a number of pictures from a recent construction event. This slide shows the completion of the leachate collection pipe at the high end of the cell. The perforated pipe is the leachate collection pipe. Gravel is placed over the pipe until the near end of it. The solid pipe in the foreground of the slide is the pipe that will bring vacuum to the gravel bedding around the leachate collection pipe. In this slide, they are cutting the excess length of the LCS pipe in order to finish the pipe. And the pipe to the right side, which is a solid pipe, is the pipe that is going to bring vacuum to the gravel bedding around the LCS pipe. Here they have completed the LCS pipe, cut the excess length, put a cap at the high end of the pipe, and the next step is to add gravel around the pipe to embed the pipe, and then the next would be pulling the geotextile over the gravel to protect the gravel. But in the meanwhile, they are going to finish the vacuum line, which you see to the right side, within the gravel kind of space. In this slide, it shows that they have completed the LCS pipe, completely embedded in gravel, and geotextile is pulled over it. The crew is sewing the geotextile in order to close the textile completely. And then behind the crew you see the pipe, which is a solid pipe bringing vacuum to the gravel. The pipe would have to penetrate the geotextile and terminate in the gravel bedding around the LCS pipe. In this slide it shows the termination of the LCS pipe, as I explained in the previous slide, embedded in gravel, geotextile is pulled over it, and to the right side you see the solid pipe which brings vacuum to the gravel bedding around the LCS pipe. Since the solid pipe is penetrating the geotextile, a geotextile boot is installed over the solid pipe and the plastic ties are visible. The boot and the sealing of the geotextile prevents sand particles that are going to be pushed over the geocomposite drainage layer from passing through the textile and then clogging the gravel below it. This is a more wide angle view of the completed work. The leachate collection pipe is to the left side, and the water in the pipe flows to the back side of the slide. To the right side, the solid pipe that brings vacuum to the gravel around the LCS pipe is visible, and the pipe extends to the outer boundaries of the cell, and at that location will be connected to a vacuum source at some point in the future. At this point, I conclude my presentation, and I thank you for taking time out of your busy schedule listening to this presentation. If you have any questions, please do not hesitate to contact me on my cell at 561-441-1473 or via my email address. Thank you.